All right. So now we will create a project file, and the name is .hmp, history matching project. If you construct using model designer, you will have snp.snp. It's simulation new project. So it's another project, and we call this history matching project. Okay, and we can create a new folder for that. Assisted history matching, enter this folder and click save. Okay, so you will get this one, configure calculations options, main settings, advanced settings, configuration summary. Simultaneously calculated models, you can increase more than one simultaneous computation, but you're going to need this. You are going to need more license if you work with other personnel who also run simulation. Better to use only one, no simultaneous computations. Okay, and the core count, basically I recommend you just to follow the default. Okay, max system threads 4, and then write results, write for wells, write properties only on last step, or write all. Okay, and then advanced setting, configuration. Yeah, just follow the default. Physical model type black oil, yes, of course. Write results value write for wells. Default can be write all, but of course you will produce many results files, which is sometimes quite uncomfortable. Core count for, and this one for Eclipse results in Eclipse form, no results. Time limit for calculation, yeah, no limit. Okay, and like delay submit until, yeah, if you want to do delay, you can use this one. Okay, and then graphs, you will input that in results folder. Okay, and then what else? Time limit for calculation for the advanced setting. Yeah, basically you will create many runs, many scenarios, right? And sometimes, yeah, due to calculation issue, due to, yeah, something, when we run the simulation, there is something called dispersion, okay, which leads to another complication in the running itself. And sometimes the combination of values can run the simulation into a divergence, okay, which will make the software confused. And for being confused, the computation can be very long, and you will just waste your time. Okay, so if you think that you have a base case that, let's say, usually can be run in just 1 hour, so if you have a particular calculation that already takes like 3 hours, you know something wrong in that scenario, in that run. And if that's the case, you want to just delete that run, because it will just lead you into something that is wrong, lead you into divergence. So you just, that is weird, 3 hours too long, just cut that. Okay, and yeah, you can use that in time limit for calculations. License wait time, also if you use limited license and in a particular run, your friends use the license that's, and you need to wait for the license. Okay, and if you wait for too long, you just want to stop the computation, you can set this in license wait time. But our case is quite Simple. We don't need to use many licenses here. We don't consume too much time, I think. So let's just follow the default. Okay, so click on OK. And we have this window, create new experiment. So number of variants, number of scenario that you want, say 25. And these are all the variables that you apply. Anisotropy, KVKH. And for the multiplier, for the permeability, for 4 fibnums. And the curvature, okay, OW and NW, as well as the, the water oil contact. This is the base value. Remember, we use set or we use multiply. And this is the min and max value. You can still change. And if you change, the cell will be colored green just to notify you. All right. And the type real numbers, and you can change the distribution. The simplest thing is using uniform distribution, but if you're quite certain any particular variable follows like normal rather than uniform, then you can use normal, or maybe log normal, triangular, discrete. If you know discrete values, truncated normal, log beta, if you know the alpha and beta variables, as well as BERT. But I think I'm going to use uniform. Okay. And pretty much that's almost all before we click on that OK button. We basically have many algorithms available in tNavigator for the experiment design. We can use custom grid search, but we'll use for the particular video latent hypercube. You can see a brief explanation of latent hypercube there. So latent hypercube sample generates variance in the following way. So we have n model variance and m variables. Basically, we have 25 variants. And how many variables there? 1, 2, 3, 4, 5, 6, 7, 8. We have 8. And then the search space is divided into n hyperplanes for each variable. Okay, and then endpoints are chosen so that each hyperplane contains exactly 1 point. So an image for n of 5 and m of 2, it will be like this. Okay, so if you want to see more, see the detailed description in AHM user guide. Okay, and you can also run Monte Carlo, Tornado, Blackett-Berman, and others. And for optimization algorithms, simplex method, PSO, particle swarm optimization, response surface, even artificial intelligence. Okay. So far, so good. So let's just click on OK. All right. So this will be the control window. We have project info, this one, and then we have calculations. Basically, now we have 26, 25 variants plus 1 base case. Okay, this is the name of the job. This is experiment 3. Okay, we use Latin hypercube. And this is the status. Directly, the first case, the base case is calculated. And the other scenarios, not the other variants are queued. So progress, already 50, 60%. It's quite fast. It's not a big model. Okay, this is the user, elapsed time, estimated time. Show finished. And I think while we are waiting for the computations, all the computations to be completed, I'm going to stop the recording and make a new video later on after we can extract conclusion from the operations. Okay, so I think that's all. And I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again later in the explanation of the history matching results. Thank you.